The I-beams make up the structure's columns and horizontal beams, while the horizontal girts between the outside columns support the fiberglass panels. Threaded rods were used for cross-bracing. Note the framing details for the vents. Hoods are installed inside the trickling filter above the vent openings, so wastewater does not flow or splash out of the vents. Once the steel was erected, the fiberglass panels manufactured by Enduro Composite Systems of Houston, Texas were installed. As shown here, each 28-foot-long panel covers the entire side, top to bottom, of the trickling filter. Along with the panels, NSW supplied butyl tape, side lap fasteners, and self-tapping fasteners. To install the fasteners, 1/8-inch holes were drilled through the panels and supporting steel. 2 men with a cherry picker can install the panels efficiently. The reinforced fiberglass panels are overlapped 7 inches and sealed to prevent leakage with the use of silicone caulk and butyl tape. Side lap fasteners were placed on the flat section of the corrugation and drilled into the support structure. Note how the fiberglass panels tuck neatly inside the outer lip of the concrete ring wall. Once the paneling is installed, openings for the doors and vents can be cut out with a reciprocating saw or other similar equipment. The door and vent hardware can be installed at any time from this point on. Ample ventilation area was provided through the use of screened openings, representing about 4% of the filter's cross-sectional area. With the structure and paneling in place, installation of the Sessil media began. Sessil consists of 30 millimeter or about 1 1/8-inch wide polyethylene strips, which are attached to wooden support boards or laths. Each lath is about the size of a 2x4 and approximately 7 feet long. The Sessil media and lath is shipped in reusable polyethylene UV-resistant bags. 20 of these bags are bundled together with straps at NSW to facilitate handling. To begin installation of the media, a temporary working platform was constructed on one side of the trickling filter. From this platform, the media was installed outward away from the platform. The Sessil laths are extremely strong and can support the weight of men installing the media. Each bundle was lifted by a crane and placed on the top of the trickling filter structure onto the temporary platform. There, the bundles were broken apart. A single shipping bag with Sessil media is opened by either untying the knots or cutting the string which ties the bag to the unit using scissors. Knives should not be used because careless slashing with a knife can damage the media. The shipping bag is allowed to drop to the bottom of the trickling filter. As this happens, the media falls out of the bag. The workers shake the media rigorously until the media is relatively straight. If any knots are noticed, the worker pulls the strips upward and untangles the strips. Workers on the floor of the filter should also make sure that the strips are fully extended and trim away any protrusions. While on the trickling filter floor, a worker can use a telescoping pole and fluff the media as shown here. This aids in straightening the media. A quick note, the media will tend to straighten out easier in warmer weather. If installing in temperatures below 60 degrees, installation could take some extra time due to difficulties in media straightening. It is recommended that all media that can be installed without requiring cutting of the support laths be completed first. Once this is done, individual laths can be cut to fit in those areas requiring shorter boards. Care should be taken during this time, as both parts of the cut board should be installed in the trickling filter. The Sessil media should be stripped off cut laths which cannot be used, and the bare laths can be cut and used as spacers where required. Once all media has been installed, all trash and scrap from the top of the trickling filter should be removed. Also, all bags at the bottom of the trickling filter should be straightened out and folded and placed into the large cardboard boxes furnished by NSW for return to NSW. These bags will be reused on other projects. An 8-inch diameter influent pipe was installed to deliver 50,000 gallons per day of wastewater through the center of the tower to the distribution system. Here, a gasket is being installed where the center mechanism of the rotary distributor is bolted to the feed pipe. With the Sessil media installed, the rotary distributor unit is the next piece of equipment to install. The distributor was supplied by Envirodyne Systems of Camp Hill, Pennsylvania. NSW recommended a motor-driven distributor because of the added process control afforded by this type design. The rotary distributor consists of a center mechanism with a rotating drum, arms which attach to the drum, and a control panel for adjusting the rotational speed of the distributor. The control panel can be mounted anywhere, but locating the unit at the top of the trickling filter is usually preferred. During installation, care should be taken to install the center mechanism perfectly level. Deflectors are attached over the orifices to evenly distribute wastewater. The Sessil trickling filter was outfitted with a ladder and platform to provide a place for an operator to inspect the operation of the rotary distributor. The operator can also make changes to the distributor's rotational speed while on the platform. A 6-foot space between the bottom of the Sessil bed and the tower's floor allows for easy inspection of the distributor's flow distribution under the media and enhances airflow through the media. This concludes our presentation of the Cott Beverages USA Incorporated trickling filter installation and operation. We thank you for taking the time to view it and look forward to assisting you on any trickling filter project requiring Sessil or any of NSW's other trickling filter medias.